Hi guys, and welcome back to Having Fun with Chemical Formulas. Hope Activity 7 went well for you and you feel comfortable now with dealing with complex ions and ionic formulae. Okay, well that sort of concludes most of the work that we're going to do on building ionic compounds. I've got two more activities for you. This one that we're going to be doing, activity 8 here, is looking at a different way of trying to generate the same sort of formulas, and there's a surprise for you in activity 9. Okay, well let's get on with activity 8 here and look at this different way of actually doing similar things to what we've done earlier. Okay, now with this activity, I've changed from the balls or the circles with the ions on to these different types of ions that you can see on the slide here. Now the cations are represented by the rectangular shapes which have got pieces taken out of them, and the anions are basically spikes. So I'm going to call the cations holes and I'm going to call the anions spikes. Now you can see that for the +1 cation there's one hole. Its corresponding anion has got one spike. Look at the cation for 2+. It's got two holes, which links with its corresponding anion, which has got two spikes. And likewise for the 3+ ion, three holes, and the 3- ion, which has got three spikes. Okay, so those are the templates that you will find on all the activities that we're going to be running through. So I will show how you will use them in a moment, but also included I have put together two slides for you which have got the cation tables and anion tables as you'll probably see them in class. Now let's look at the cation table here. Now I have included some little extras. Now if you can remember back a few activities, I talked about the transition metals. Now circled here there are a few transition metals: copper Cu, which is shown with the blue circles, iron Fe, which is shown with the green circles, and tin Sn, which is shown with the orange circles. Now the unusual thing about transition metals is they can exist in a number of different forms with respect to their ions. You see here copper with blue circle can exist as a Cu1+ ion or a Cu2+ ion. Iron in green can either exist as an Fe2+ ion or an Fe3+ ion, and tin can exist either as an Sn2+ ion or an Sn4+ ion. The highs and the hows and wherefores as to why they occur probably will be studied later on in either another course or higher up in your chemistry. For now we just need to know how to use them. Now if we were to write, let's take something like iron. If we were to write down the compound, it's always written as iron with the Roman numeral 3. That means that the Fe3+ ion is used. If you see a compound where it says iron and then in brackets the Roman numeral 2, that means that the Fe2+ ion is used. Similarly with copper, if you want to show copper 2, you write it as copper and then in brackets 2 Roman numerals, and that will mean that you're using the Cu2+ ion. They're going to be utilized later on throughout the activity, so I just thought I would explain them for you. Here's the anion table for you. These are the ones that we use at St. Hilda's, and you'll have similar ones, I'm sure, in your schools. Okay, let's get on and have a look at some of the examples. Now, I'm only going to show you one example because you'll, by this stage, will understand what we're trying to do. All we're doing is just using different shapes. So in this example, what we're going to do is work out the chemical formula of sodium sulfate. Remember that the sulfate is a complex ion. You've already had good practice with this, so it should be okay. So first off, sodium sulfate, we need to determine what are the ions we're going to be using. Well, the first one we're going to have is sodium. We know that's Na+. So it's a 1+ ion. And then we've got sulfate. If you remember back from complex ions, it's SO4 2-. Okay, so we know we've got a 1+ cation and we've got a 2- anion. So what we need to do is go over to the toolbox on the right hand side. So let's start off with the positive, and I'm going to bring across underneath the example 1+ cation. There it goes. So that's going to represent my sodium. I'm also then going to bring over my 2 minus sulfate ion. Here it comes. Alrighty, now you'll see what we've tried to do. The spike fits into the hole. Now in order for the chemical formula to be stable, we must make sure that there are no open holes or spikes. Now you can see here there's a spike that's empty. The only cation that I can use, the only hole that I can use to cover the spike is the sodium, or 1 plus. So you can see I need one more. So I'll bring that across. Now you can see that the green holes cover all the red spikes. We now have a complete chemical formula. So how do we work out what we've got? Well, it's quite simple. All we need to do is say, how many cations have we got? Well, we've got 2 green holes. Those 2 green holes basically represent the sodium. So we've got 2 sodiums. The red spikes is made up of 1 sulfate ion. So I've got 1 sulfate ion. Now, hopefully, you'll be able to see now, there's the symbol Na, we've got the symbol SO4. We know that when we write we have more than 1 atom of each ion, all we're going to do is put it as a subscript. So the actual formula is going to be Na2SO4. Remember, the Na2 corresponds to the 2 green holes. The SO4 corresponds to the 1 2 minus anion. I hope that makes sense. So what I'd like you to do is have a go at activity 8. There are plenty of examples here that you can use. So all you have to remember is to make sure just pull across the cations, pull across the anions, and just cover the spikes or cover the holes until it's completed, and then write down as a subscript next to each of the formula what the number of ions that you've used to make the complete formula. Okay, there are answers on this on the course outline, so check them first, and good luck. Thanks for watching.